Hi there, this is Cheng-Zong Huang, and I'll be walking through an experiment project that focused on predicting and analyzing liver cirrhosis, kind of severe liver disease. The project will be using the data from the Mayo Clinic trial in primary biliary cirrhosis of the liver conducted between 1974 and 1984. The whole data set contains 418 observations. With the help of this project, the doctors can have a better chance of disease diagnosis and stage identification, and furthermore, help the patients to manage themselves. It is the crucial value of this project since liver cirrhosis as a late-stage liver damage condition requires timely treatment and care. And through this video, I'll be introducing each step, how this project achieves its final goal, and those steps are install the libraries needed, knowing the features and the variables, preparing the data for later analysis, and finally implementing the machine learning models. So let's turn our eyes to the notebook. The first step is just quite straightforward. Install all the libraries needed, and those are pandas, Seaborn, Matplotlib, NumPy, scikit-learn, LMB-learn, and etc. So let's look at the data set. There are 20 variables in total. Some are basic information such as age and sex. Some are medical related like bilirubin and hepatomegaly. They also conduct an exploratory data analysis by checking the dimension and each variable types. He then drops the ID column. He displays the feature types into quantitative features versus categorical features, those two subtypes. He checks the NAs and the duplicated values, which will be dealt in the next step, the preprocessing. He uses the describe function to have a more holistic view of the whole data set. For the preprocessing, he first replaces all the missing values with 0, and he replaces stage 4 as 1, and the rest of the stages as 0 because he only wants two outcomes: cirrhosis versus no cirrhosis. The skewness is applied here, and the Turkey rule is applied to identify the outliers. For the categorical features, he chooses domain encoding. One highlight here is that he also involves a heat map of those critical features and the correlation between them. Just look at this matrix. For the machine learning part, he first splits the whole data set into training versus testing subsets with 80 to 20 ratio split. He has the features standardized and applies mode to balance the training set. He creates a pipeline that includes a scaling and balancing with mode and a decision tree classifier. He fits the pipeline on the holdout training set and predict on the testing set. He also evaluates the predictions by constructing a confusion matrix. The accuracy is about 64.3% on the testing set. By using the PyCaret, they also tries a couple of methods that are tested and evaluated using the matrix, such as accuracy, area under curve, recall, precision, F1 score. After selecting the best model, he then tries to tune the model. However, the original model performs better than the tuned model, so we just choose the original model. Since the outcome is the dichotomized, the classification method of machine learning is suitable for this scenario. Also, with help of the PyCaret, The author can compare different models with merely a single line of code and select the best one among them. This notebook provides a comprehensive approach for healthcare providers to identify whether a patient has liver cirrhosis or not using machine learning. The final selected model is able to achieve a relatively high accuracy for predictions, but also it can be improved by merging with a more diverse training data set. It also inspires that more and more medical diagnosis can be done by machine learning in the future, which can help healthcare providers timely adjust the treatment so that it enhances the patient's survival rates.